Okay, alright guys, let's continue, yeah. Alright. Last week we started with applications again. So we have total 6 different applications. We have started with the first application last week. The first application that we have covered last week is called metal displacement. Okay, we have covered this on last week, yeah, the first one. So we have another 5 more to go. Today we will do the second one. The second one that we learned today is called Halide displacement. We will learn this. If you attended the class last week and you fully understand what we learned from last week, it's going to be very easy to you because they are very, very similar. Okay? After that, you have a conversion from Fe2 plus to Fe3 plus, Fe3 plus to Fe2 plus. This is next week. Then we have something called YouTube. We have something called rusting. And lastly, we have reactivity series. So there are 6 applications out there. Don't worry guys, this was the last chapter which is super lengthy. After this, all the chapter will be very short and very simple. So metal displacement is already covered last week, okay, in our last lesson, yeah? So now we will continue today with something called halide displacement, okay? We will cover halide displacement by today, yeah? Okay, let's start with the word. Let's start with the new subtopic called halide displacement. Alright. Okay guys, I mentioned last week, when you saw the word displacement, it's all about gangster bully concept, yeah? When you see the word displacement, it's all about gangster bully concept. Please recall back, what is gangster bully concept? A more powerful fella rob and take something from the less powerful fella. Okay? Guys, what is the only differences between today and last week? There are so many things similar. Last week, the gangster are those metal. Last week, those gangsters that rob each other, they are metal. Today, you change the gangster. Today, the gangster is halide. Guys, what is halide? Halide is something come from group 17. You learn back in your form 4. Are you with that? Now, everyone, before we start, there's something very important you must know. In this chapter, which is not very hard, many people having hard time to differentiate these 2 words. The first word is called halogen. The second word is called halide. Many people cannot differentiate halogen and halide. Yeah? So I want you all to know a difference. Guys, halogen is referred to group 17, okay, neutral molecule. So halogen, they are neutral and they always come in molecule. Okay, example, Cl2, no charge, is halogen. Br2, no charge, is halogen. I2, no charge, is halogen. Halide, on the other hand, halide also come from group 17. But the only difference is what? Halide is group 17 ion. When I say ion means what, guys? Got charge, alright? So Cl minus, Br minus, I minus. So please be careful. If you come from group 17, you don't have charge, I call you halogen. If you come from group 17, you have charge, I call you halide. Are you okay with that? So please be careful. Please make sure all of you able to differentiate, able to distinguish halogen and halide. Huh? Okay, now come to the name. A lot of people also name them wrongly. When you are halogen, when you are neutral, the name is called chlorine. This is called chlorine. Br2, the name is called bromine. I2, the name is called iodine. When you got charge, the name will be slightly different. When I say slightly different, I mean that because the name only differ in one letter, one word. If you have charge, I don't call you chlorine. I call you chloride. Okay? So when you have charge, I don't call you bromine, I call you bromide. When you have charge, the I, it doesn't call iodine, you call iodide. Please be careful. I have seen so many people name it wrongly. Bromine, they go to name bromide. Chloride, they go to name chlorine. So please be careful. Only one letter difference. And you also learned before, guys, Cl minus, Br minus, I minus, all these guys, they got charged. In chemistry, anything got charged, the name must end with ion, yeah? In chemistry, whenever you want to name a substance and that substance got charged, the name must have a word ion. So far, so good? Okay, so please be careful with this. Then some people say, sir, sometimes I forgot lah. I kind of like, I know one is chlorine, one is chloride, but sometimes I forgot. How you do that? You just need a simple common sense, and the name tell you some hint, guys. Why? Look at here, chlorine. The name is N. N stand for neutral. N stand for neutral. Understand? Chlorine got N1, it is neutral. Bromine got N, is neutral. Iodine got N, is neutral. Are you okay with that? So please make sure you all know this, the naming, halogen and halide. Very, very important. Okay, now, let us kickstart with the concept. So what is the concept of halide displacement? It's absolutely same as the metal displacement. More powerful, rock less powerful. But there's a small difference, guys. Recall back from last week. When we do metal displacement, a more powerful metal gangster want to rock something from a less powerful metal gangster. When you have a bunch of metal, how on earth you know which metal is a more powerful or less powerful gangster? We learned from last week, ECS, right? But now, you don't do that. Now today you change it. Now today the gangster is halide. So when you have halide, to know who is a more or less powerful gangster, you no longer need to refer to ECS. So what you can refer? Now you just refer to the periodic table, group 70. Understand? As simple as that. Okay, so now in order to know which, halide or halogen, which halide or which halogen is a more powerful gangster. If you want to know which halide or which halogen is a more powerful gangster, you go to refer, not ECS already, you not refer to ECS, that is for metal displacement, you refer to the periodic table. You just refer to your periodic table, your group 70, okay, which is something like this: chlorine, bromine, iodine. This is your group 70. The higher you are in the group 70 table, you are a more powerful gangster. Okay? The higher you are, the more powerful gangster you are. The lower you are a less powerful gangster. So what I'm trying to tell you is that a lot of concepts we learned today same as last week, okay? There's only two differences. Number one, last week those gangsters are metal. Today, those gangsters are group 70. Last week, to know who is a more powerful gangster, we're referring to ECS. Today, to know which fella is a more powerful gangster, you refer to periodic table. Understand? I want you to see the connection. When you can connect, it's going to be easy. Okay? Alright, because more than 80% of what you learned today is same from last week. Okay, now, let me use two examples for demonstration. Let me give you three simple examples for demonstration. Let's say the first example, everyone copy first, just follow me, come on. The first fella I put here is Cl2. Let's say I have a Cl2 called chlorine, no charge, called chlorine. I go to react with a fella called Ki. Ki called potassium iodide, potassium iodide. Okay? So now what happened here? You all can see chlorine is group 17, iodide is group 17. When two group 17 people come together, when you have two group 17 people appear together, this is halide displacement. When you have two metal appear together, that is metal displacement. Understand? You get it? For example, today if you have this from last week, magnesium react with copper sulfate. Magnesium is a metal, copper is a metal. When two metals met together, that is metal displacement. Understand? Today, when two group 17 fella meet together, that is halide displacement. Okay, what is halide displacement all about? By me saying that, displacement is all about gangster, bully concept. Now look at here. Chlorine is somewhere here, iodide is somewhere here. Chlorine, Cl is higher than I. Cl higher than I, which means Cl is a more powerful gangster. So when Cl is more powerful, Cl can bully and rob something from the other person, which is the I. So Cl go in here, Cl go in and rob the K. So when the K robbed by the Cl stick together, you form KCl. Okay? Now, not KCl2, KCl. Cl go in and sticking with K, KCl. Now, when the K is taken away from the Cl, the I now come alone. You never see I come alone. If I come as one piece or alone, it must be I2. So far so good? Okay, and if you realize the equation is not balanced, yeah? You have 2 chlorine on the left, you have 1 chlorine on the right. You should put a 2 here. When you put a 2 here, the potassium becomes 2. The potassium here still 1. Put a 2 please. When you put a 2 here for the potassium, the iodine becomes 2. Now the iodine also got 2. Perfect. Are you okay with that? Now this concept called halide displacement. Not very hard, yeah? Okay, we try another one more together. Let's say today we have another fella. What if we try this, guys? This is a bromine, and then this is a potassium chloride. Can we try this together? Okay. Bromine is group 17, chlorine is group 17. When 2 group 17 fella met together, halide displacement, yeah? So halide displacement is gangster bully concept. Who is fighting now? Bromine and chlorine. Eyes on here. Bromine is here, chlorine is here. Bromine is lower than chlorine. Bromine is a less powerful gangster. So bromine cannot rob anything from the more powerful chlorine. What happened? Nothing. No reaction is happening or occurring. So far so good? That's it. So not very hard, huh? Okay? If you understand what you learned from last week, what you learned today should be quite easy for you. Okay? So this is what we are going to do. Okay, we will still employ the same strategy as last week. The strategy you don't need to copy is exactly 100% same as last week. This one just for revision, you don't need to copy. So what is the strategy for us to solve redox question? I told you last week. In redox, first and foremost, always go to write a good chemical equation first. After write a good chemical equation, please try to convert the chemical equation into ionic equation. And after you get ionic equation, we are not happy. We must go to get half equation. I mentioned last week, in this chapter, you must know half equation. In this chapter, you must know how to get half equation. Half equation is the king. I mentioned that, yeah? So once you have the half equation, you can use the half equation to do something. The half equation can be used to do 2 things. You can go to do redox analysis. Redox analysis means apple to apple comparison. Second thing, you also can use half equation to give people the observation. Okay? You can use the half equation to tell people what you see. Get it? This one no need to copy, it's all from last week. If you are here, this is nothing new, okay? This is exactly the same thing we learned from last week. Okay guys, you jot down the rest first, you jot down the others, then we go on and we do 2 technical examples, okay? I'll run through 2 examples technically using this. Then I'll let you all try some questions later on. Okay, come take your time. Okay. Right guys, we will try to do 2 examples on what is happening here. So please listen carefully. 2 examples on halide displacement. This is the first example. Let me draw a picture so you have a better idea. You have a test tube. This is a test tube. This test tube inside contains a solution. The solution in the test tube, let's say I call it as potassium bromide. Okay? So on top here you have a small dropper. Dropper is a special small tools or apparatus for you to add in a small amount of liquids. Understand?
Yes.
Alright. So if this liquid to be added, I call it as chlorine water. Okay, I call it as chlorine water. Okay? So I'll tell you what is chlorine water in a short while. Don't worry. Okay, so this is the one. Okay, now guys, please remember the basic principle. In the chapter redox, it would be fantastic if you can get half equation. Okay? So we must try to get half equation. When you first started, you couldn't get half equation immediately. Later on, after 1 or 2 more classes, I'll teach you some shortcut how you can get half equation instantly. But for now, you have to go through the very long, boring process, but very effective. We start with a chemical equation first. Can all of us try to write the chemical equation together? Okay, let's try to do the chemical equation now, guys. Chlorine water. Chlorine. The word N stands for neutral, no charge. When no charge, chlorine is written as Cl2. Yeah? Good. Now, potassium bromide solution. You learn about this in your Form 4 Chapter 3. In chemistry, whatever name they gave to you, you should be able to predict the formula, not memorize. Example, if I say aluminium oxide, you all should know, aluminium, the charge is Al3+. Oxide, the charge is O2-. When the charge is different, you do a cross method. A 3 goes to the right, a 2 comes to the left. Therefore, aluminium oxide formula is Al2O3. Are you okay with that? This is how you predict the formula, not memorize, yeah? Okay, now, let's do it. Potassium bromide, can we try? Potassium ion, the charge I know is K+. Bromide ion, I know the charge is Br-. K+, Br-, the charge is +1 and -1. When we have same charge, what to do? Cut the charge and stick together, yeah? Just cut the charge and stick together. Therefore, potassium bromide, the formula is K-Br. Understand? No memorizing, yeah? Okay, now you have successfully get the formula for the chlorine water, which is Cl2. You have successfully get the formula for the potassium bromide solution, which is Kbr. Now, let's finish it. They didn't tell us what happened on the right-hand side. We must predict ourselves. Chlorine is a group 17 substance. Bromine is a group 17 substance. When two group 17 substance come together, this phenomenon called halide displacement. Yeah? So, halide displacement, chlorine is higher than bromine in, not ECS, in group 17. Chlorine is a more powerful gangster than the bromine. So what? So chlorine can go in and take the K away. So when the K is taken by the chlorine, you form KCl. Are you okay with that? Now, when the bromine, the K, which initially belongs to the bromine, is taken by the chlorine, now the bromine got nothing left. So it's Br. You never see Br appear alone. When Br come alone, it always appears as Br2. Understand? So when you do chemistry equation, it's a must to make it balance. So let's balance it. 2 chlorine, 1 chlorine, put a 2. 2 potassium, 1 potassium, put a 2. 2 bromine, 2 bromine. Is good. Clear? Okay, now after you get the chemical equation, let's try to make it become ionic equation. So ionic equation is the equation that got charge. So what you should do, list out the charge. Again, please remember again. What is the charge for the chlorine here? No charge, because the chlorine here is one species element. Anything made by one species, they are element, they have no charge at all. Copy back, yeah? So what is the charge for potassium? K+. How many potassium we have? 2. What is the charge for bromide? Br-. So the Br got 2 here, yeah? Because the 2 belongs to the K, belongs to the Br. So far so good. Okay, go to the right hand side. Potassium, K+. Potassium got 2 pieces. Chloride, the charge is Cl-. You have 2 also. The bromine here is one species element, no charge. So okay? Compare left and right hand side, we notice that the K doesn't change in the charge. Anything the charge doesn't change, cancel out or cut off. So just cut it off. So we cut off the K, we cut off the K. Understand? So this whole thing is ionic equation. Okay, ionic equation is really good, it's fantastic, but we are not satisfied because in this chapter, what is the important thing? Half equation. And guys, I say many times before, how many half equation we have? 2. We always have 2 half equation, right? So let's make this thing become 2 half equation. How we make them become two half equation? We split them according to the right species. So the first species, I choose Cl2. Cl2 on the left hand side should be paired up with the Cl minus on the right. Okay? So this is my first half equation. Second half equation, Br minus, 2Br minus on the left hand side should pair up with the Br2. Alright? Because you pair up those species that is in common. Understand? No way you go to pair up Cl2 and Br2 become an equation because they have no relationship at all. Clear? Okay guys, are we satisfied over here? No, because half equation is the equation that got charge and electron. Okay, so we have the charge but we don't have the electron. And I told you previously, I told you last week, I told you the week before that. When you come to electron, first thing you must ask yourself how many electrons you needed, right? So the amount of electron is decided by what? The total charge differences. Okay, everyone, total charge on the left hand side is 0. You don't see anything here, no charge, 0. You have no charge on the left. Huh? This further, what is the total charge? Negative 1 times 2, so it's negative 2. 0 and negative 2 charge differ by 2, so we need 2 electrons. So now we know the amount of electron we needed. Electron should put at where? The more positive side. 0 is more positive than negative 2. Therefore, you put the electron on the left. Understand? Get it? Don't memorize but understand it. Second thing, what about this? Okay, total charge of the bromide is negative 1 times 2 become negative 2. Total charge of bromine is 0. Negative 2 and 0 charge differ by 2. 2 electron is what we need. Electron should put on the more positive side. 0 is more positive than negative 2. Therefore, we put the electron on the right hand side. So far so good. So we have successfully obtained the half equation. For me, whenever you can get half equation, it's always a good news. Clear? Alright? So now we have get the half equation that we want. Don't memorize half equation but learn how you get it. Okay, so far guys, up to this point, any question to ask me? Yes.
There's 2 chlorine on the left and 2 chlorine on the right. When can we cancel both?
You only can cancel the number in front.
Oh.
Example, the number in front is 2A. And then on the right side is 2B. You cut the 2 in front.
Oh.
You cannot cancel here because the 2 here is at the back, the 2 here is at the front. Understand? Good question. Okay? You only can cancel or simplify the number in front. Good one. Okay? Any other question, guys? Good. Alright, now let's go on. Okay, now we will try to use the half equation that we obtained to do a redox analysis. So guys, now let's do something called redox analysis. So what is redox analysis? Redox analysis means apple to apple comparison. Okay, in SPM, there are total 4 methods we learned before: oxygen method, oxidation number method, electron method, and hydrogen method. The one that you must know is oxidation number and electron. Must know. Clear? Now, let's say for this example, we use electron method. Okay, let's say we use electron method for our example number 1. Later on, example number 2, I use oxidation number method. Okay, now let's do together. Okay, no matter what method you use, remember who is your best friend to help you? Half equation. Let's copy the half equation. The first half equation is Cl2 plus 2E become 2Cl minus. Okay, now I want to use electron method. Guys, we learned before. If you want to use electron method, if you want to know whether you are donating or receiving electron, you must watch out the location of electron. So in this particular case, the electron is on the left. So when we are standing here, the electron very close to us, we receive, yeah? Good. Now, you know receive. Fantastic, guys, but be careful the name, guys. You can write it as, who is the recipient? This fella, right? This fella, Cl2. If I want you all to name it, Cl2, we call it what? Chlorine. So this fella called chlorine. So our chlorine go to receive. If you don't want to write the word receive, you can go to write the word gains. You also allow to write the word accepts. Okay? So the chlorine go to receive, gains or accept how many? 2 electrons. Okay? So when you receive electron, what process is happening though? Reduction, yeah? You can check the table, the one below in the first lesson. Receiving electron is reduction. So your chlorine is actually undergo reduction. Okay? Receiving electron means reduction. Very good. When you undergo reduction, you are oxidizing agent. So chlorine will automatically be oxidizing agent. So nothing hard, right? I mean, we have been practiced, we have been doing this for quite some time, isn't it? Okay, that's it. So the whole chapter, very boring one, is all about this. Okay? Because the whole chapter is all about answer 4 question. Who undergo oxidation, who undergo reduction, who is oxidizing, who is reducing agent, that's all. Okay? Right now, center one. Okay, we're not done yet. We have one more half equation to go. Now, let's refer to our second half equation. The second half equation is here. Come, let's transfer to here. 2dr minus now become dr2 coupled with 2dr. This equation I didn't memorize, I produced it myself just now. Same thing, I want to use electron method. To use electron method, we all must be very sensitive with location of electron. In this particular case, the electron is a bit on the right hand side. So imagine I said before, we are standing on the left and the electron now is on the right, electron far away from us. What happened? We throw it. You cannot write the word throw, you must write donate or lose, okay, or release. Good. Guys, now a good question. Who throw the electron? This fella. How do you call this fella, bro? Bromide. Understand? Bromide. If you write bromine, sorry. Understand? One letter wrong, gone. Here, bromide. Okay? So this fella called bromide. Because this fella got charge, the name must add along with the word ion. Yeah? So bromide ion can go to donate. You can write donates. You can write the word releases. You also can write the word loses. No problem. How much? 2 pieces, 2 electron. Okay? Settle one. So when you donate, release or loses 2 electron, what happens? In chemistry, in redox, when you lose electron, the process happening is oxidation. So this fella, copy back, bromide ion, this fella, bromide ion undergo oxidation. Or you can put in the past tense, bromide ion is oxidized. It's okay. Here? So when you undergo oxidation, I know already the bromide ion, when you undergo oxidation, you're supposed to be reducing agent. So far so good? I hope you feel comfortable with it. It's not very hard, isn't it? Okay? It's something that you learned before, right? The logic, the step by step. So far so good? Okay. Any questions so far, up to now? Good, huh? Right. If you realize that, guys, we use the same recipe as last week, isn't it? Okay? It's all about what? Half equation, half equation, half equation. Okay, last one, observation. Okay, guys, observation in this subtopic is a bit tricky. I repeat, observation in this subtopic is a bit tricky. Listen carefully. Why? Because a lot of you were confused with something you learned back in your Form 4 chapters 4, periodic table. Why? Look at here. Come on. Listen carefully. Okay, the last thing we will learn is called observation. I told you last week, observation is always referring to what we can see, what we can see. And if you want to get observation, please remember, always refer to your good friend, half equation, okay? Always remember, make good use of half equation. You all can use the half equation to predict the observation, yeah? Okay guys, listen carefully. The observation is a bit trickier. Watch out, eyes on here. This is the observation you need to know. You all need to know some color. You must know the color for 2 fella. The first one is called halogen. You must know the color for halogen. The second one, you must know the color for halide ion. They are a bit different, yeah? Halogen and halide are a bit different. Listen carefully, yeah? Okay. I will tell you what you learned previously and what is your problem. I want you to listen to me. What is your problem and avoid that. Okay, you learned about 3 halogen in your SPM Form 4. Chlorine, bromine, and iodine. Watch out. In SPM, if any one of you remember in your Form 4, chlorine, which is your Form 4 chapter 4, chlorine appear as, if you all remember, is a greenish yellow color gas. Chlorine naturally is a greenish yellow gas, okay? Second thing, bromine naturally is a brown color liquid, okay? Bromine supposed to be a brown color liquid. Iodine naturally it should appear as a purple or purplish black color solid. So this is their color naturally. Now the bad thing is that none of them can be used now. Why? Why? If I say what is the color for chlorine? Greenish yellow. Awesome. But guys, I don't want chlorine. Look at that. Look at the picture yourself. I want chlorine water. Hey, sir, in this chapter I saw chlorine water, bromine water, iodine water. Actually, what is it, sir? Chlorine water means that you take the chlorine, which is a greenish yellow gas, you dissolve it in water. Understand? To form a liquid or solution. Bromine water means what? You take your bromine, dissolve in water to make a solution. Understand? So you take your halogen, dissolve in water already. When you dissolve the halogen in water, it becomes something else already. So the color shouldn't be this already. Are you okay with that? So now, learn this. The color for chlorine water is pale yellow. So chlorine water is pale yellow. The color for bromine still perfectly fine, brown. Okay, perfect. The color for iodine is also brown. Now this one a bit confusing. Later I'll teach you how to differentiate, don't worry, okay? So be careful. Chlorine water is pale yellow. Bromine water is brown. Iodine water is brown. Are you okay there? How does them different from what you learned previously? What it means by iodine water? Sir, why we don't use purple black? You use purple black when the iodine appear in the most nature form. If the iodine you not dissolve in water, it is a fantastic, nice purple black solid. But now you took the purple black solid to dissolve in water to form iodine water. When you dissolve something in water, something happens, there is a reaction. That's why the color might not be the original one. It becomes brown. So far so good? Okay? Halide, simple. No matter chloride, no matter bromide, no matter iodide, don't care. All halide, all group 17 ion, all halide ion, they are colorless. This is simple. Understand? Chloride, colorless. Bromide, colorless. Iodide, colorless. Hey, watch out, Chloride is colorless. Chlorine is not colorless. Chlorine is pale yellow. Understand? Get it? Iodide is colorless. Iodine is not. Iodine is brown. Clear? So at the end of the day, you don't confuse yourself by what? Chlorine, chloride. Understand? It sounds so easy. Actually, this chapter not very hard, but a lot of people get wrong with some simple thing. Chlorine, chloride, bromide, bromine. Understand? So far so good. Now, everyone, follow me. Let's do together. How we use our good friend half equation to get the observation. Follow me. Let's copy the half equation here. And I want your participation. Follow me, everyone. Come on. This is the half equation that we produced just now. Are you okay with that? Now, everyone, you tell me. Okay, I want to hear from you. Okay, this fella is Cl2 in the first place. Cl2 is chlorine. Everyone, can you tell me what is the color for chlorine? Pale yellow. Can refer, it's okay, no need to memorize one first. Okay, today you can refer. Look at that, don't make a wild guess. Refer to that. Chlorine is pale yellow, okay? So chlorine is pale yellow originally. Very good. Electron what color? Don't tell me what color, I got shocked. Don't care. Electron don't care. Focus on here. Chloride. What is the color for chloride, everyone? Colorless. All halide are colorless. Fantastic. So guys, now what do you see? From pale yellow to colorless, you can see something? Yeah, pale yellow to colorless, there is a color change. Which you can see it. Understand? But you must mention this. You know, a lot of people, their answer is what? They write pale yellow to colorless. No mark at all. Because you didn't tell people who changed from pale yellow to colorless. I don't know. Clear? You must specify. How you specify? You ask yourself. This pale yellow come from who? Cl2. Who is the Cl2 from the picture? From this picture, who is the Cl2? Chlorine water. So how you write it? You write it this way. You just need to write chlorine water. Go to change from pale yellow to colorless. Chlorine water change from pale yellow to colorless. Simple as that. Again, you can restructure your sentence. Some people, they don't like to write this. They will change a bit. You also can write this. Some people, they write this. Some people, they write pale yellow of chlorine water decolorized. Okay, what? Same meaning, what? Come on. So you can play around as long as in the answer I saw the word chlorine water, I saw the word pale yellow, I saw the word colorless. I'll give you full mark. So far, so good. Okay? Second one. Can we predict another one half equation? Why not? Look at second half equation. Everyone look at here. 2 bromide ion becoming bromine coupled with 2 electron. Now this is our second half equation. Can we do the same thing to predict the observation? Why not? Everyone start from the left hand side. Left hand side you have Br minus. This fella got charged. It is halide. Halide what color? Halide? Colorless, colorless. So bromide is colorless. Okay. Now the bromide eventually became bromine. Bromine what color? Brown. Okay? Colorless to brown. So when colorless change to brown, you can see color change, right? Or not? Same thing, you must tell people who changed from colorless to brown. Okay, everyone, let me ask you. Who is the owner that changed the colorless to brown? These colors come from who? Br minus. Huh? Everyone look at the picture. They give you a picture, use it. This picture, you think who is the Br minus thingy? Potassium bromide, right? This color is potassium bromide. The Br minus is coming from here. Yeah? So write it up. So your potassium bromide, your potassium bromide solution will actually change the color from colorless all the way to become the brown. So you can clearly see that. So far, okay? Not very hard, yeah? So when you want observation, don't memorize, refer to half equation. So far, so good. Not very hard, but I think the observation for halide displacement is slightly trickier compared to metal displacement. Because when it comes to halides, many people, they mess up the color between halogen and halide. Okay, they mess up the color of halogen and halide. And some people, for the halogen, they mess up with the color they learn in their form 4. Okay, many people, the chlorine here, they will write greenish yellow. No. Okay, you only write greenish yellow if the chlorine comes in the purest form. This chlorine is not pure. Why? The chlorine already dissolved in water. Your chlorine is added with water. You are not pure already. Understand? Okay. Jot down on this. One more example coming up. Yeah. So we will do total 2 examples only. Hopefully, these 2 examples give you a very good understanding. Yeah. That's why I say if you are here last week, you not only attend the class, if you understood what you learned last week, it's not going to be hard for you, okay? Because you can see the whole concept is the same. The only thing different is that the gangster today is no longer the metals. Today, the gangster are group 70. That's it. Okay? Okay, so guys, let's do the second and the last example together. So now, I will just do some minor changes. This is example number 2. For example number 2, instead of using chlorine water, I would change it and use something called bromine water. Okay? So now I will use a bromine water instead. Then for this solution, instead of using a potassium bromide solution, I will change it as well. Now the solution, I would use something called sodium iodide. I'll use something called sodium iodide solution. Okay, let's do this all over again. So let's erase it and let's redo the whole process again. Okay, let's start. Same thing. First and foremost, you must be able to write a good chemical equation and slowly convert to half equation. Come, let's start with this. So we will begin with the chemical equation. So let's write the chemical equation together. We have a bromine water, bromine, the name ended with N, N stands for neutral. Neutral bromine formula Br2. So we go to react with something called sodium iodide. We can predict the formula for sodium iodide. Sodium, the charge is Na plus. Iodide, the charge is I minus. Plus 1 minus 1, the charge is cancelled out. So sodium iodide formula is NaI. Okay? Bromine is a group 17 fella, iodine is a group 17 fella. 2 group 17 mixed together, halide displacement. Bromine higher than the iodine in group 17. Bromine is a more powerful gangster. Bromine will rob the Na away from the I. When bromine take the Na away, it becomes NaBr. Yeah? When the Na taken from the iodine, the I stand alone. I stand alone, but to write I2. Okay? So now let's balance the equation. Put a 2 here and put a 2 here. I hope everyone knows why. Okay? So we have a balanced chemical equation. Now we want to get the ionic equation first before we get the half equation that we wanted. Let's go for ionic equation. Ionic equation, you can get it by listing out the charge. Bromine is a one species element, no charge. Sodium is Na+. As you all can see, there are 2 sodium over here. Iodide, the charge is I-. You have 2 of it. On the right hand side, sodium is Na+. You have 2 of it. On the right hand side, bromide is Br-. You also have 2 of it. Okay? Iodine here is one species element. Anything one species, no charge. Just copy. Compare left and right hand side. Is there anything we could cut? Yes. 2 Na+ on the left, 2 Na+ on the right. The charge doesn't change. Cut it off. Okay? So upon cutting, upon simplifying, we get the ionic equations already. After that, the ionic equation can be further break down to become 2-half equation. So how you get the 2-half equation? Do the pairing, yeah? Bromine on the left should be paired up with the bromide on the right. Let's copy. Bromine on the left, pairing with 2 bromide on the right. Second one, iodide on the left. So iodide on the left hand side can go to pair up with iodine on the right. Okay, we are not done yet because half equation not only need the charge, you also need the electron. Please remember, the amount of electron you must figure out. The amount of electron is decided by total charge difference. The amount of electron is decided by total charge difference. Total charge on the left is 0. Total charge on the right is -1 times 2, -2. These are the total charge. 0 and -2 charge differ by 2. 2 electron is what we need. Put the electron on the more positive left hand side. Okay, what about this? Total charge on the right hand, total charge on the left hand side is -2. Total charge on the right is 0. -2 and 0 charge differ by 2. 2 electron is what we need. Electron put on the more positive side. Settle. So far so good? Okay, so we have successfully get the half equation. Okay? Settle. This thing you can erase in the end. Don't keep this because if you keep this in your paper, sometimes you lose the mark because sometimes you don't understand your working. So this one, after you do on the draft paper. In the end, this thing erase it. So far, okay? Alright, now let's go on. Okay, once we have half equation, we can use the half equation to do whatever thing we want. Yeah. Okay, in redox, there are only 2 major things you should do. The first one is called apple-to-apple analysis. We call it redox analysis. Come, everyone, let's use the half equation to do redox analysis. Just now, for example number 1, we already used and employed electron method. Now, I will use oxidation number method. So for this example, I would like to use oxidation number method. We learned about oxidation number approximate 3 weeks ago. I'm not sure how many of you still remember. Okay? You can flip over to the notes if you forgot. Okay, come. Now let's use oxidation number method. No matter oxidation number or electron method, please remember who is your best helper or companion. Half equation. Understand? Just bring the half equation on the table first. No matter what method you want to use. Come, let's copy the half equation. Br2 plus 2E become 2 Br-. Everyone focus here. It's not very hard, but a lot of people will mess up already. Listen to me, I'll tell you which part you might get confused and you have to try to avoid it. Come, I wanted to use oxidation number method. Whenever you want to use oxidation number method, you must first go to list up your oxidation number. ON is the short form for oxidation number. Yeah? How you get your oxidation number? 3 weeks ago, 3 lessons back, we learned something called 4 rules. There are 4 rules can help you to predict oxidation number. You all can flip back to the notes if you have forgotten. Here, you have the notes, just flip back and refer. Yeah? Come, everyone, I need your participation. Yeah? Bromine. The bromine on the left hand side is one species element. Oxidation number 0. Very good. Now, this is not a problem. The problem is here. Listen, okay, I want to listen from you, everyone. What is the oxidation number for the bromide here? Negative how much? 2? No, -1. Understand? That is the problem. Sir, how come just now -2? Now how come -1? Okay, for oxidation number, you don't need to sum everything together. For oxidation number, you don't need to sum the whole thing together. Are you okay? No matter you have 3 bromide, 4 bromide, or 7 bromide, the oxidation number just copy the charge of 1 bromide, which is -1. Clear? But whenever you want to find out the total amount of electron, when you want to find out the amount of electron, you need to find the total charge. Are you okay with that? You find total charge when you want to figure out the amount of electron in the half equation. But now, I'm not looking for the electron thingy. Now, I want to do oxidation number analysis. So when you want to do oxidation number analysis, you don't need to sum everything one. Clear? So please be careful. Many people still thought it's -2. Understand? So please be careful. Okay, now let's finish it. Okay, 0 to -1. This 0 and -1 belong to which species? Br. So let's write in words. Oxidation number. Oxidation number of this fella. Br species. When oxidation number, you must mention which species the oxidation number. Br. So Br oxidation number from 0 to -1. 0 to -1 means decreases. Oxidation number decreases from 0 to -1. So when oxidation number went down from 0 to -1, what process happening? Reduction. So who undergo reduction? Whose oxidation number changed from 0 to -1? This fella. This fella is Br2. Br2, the name called bromine. Br2 called bromine. Don't call bromide. So your bromine undergo oxidation. So when bromine undergo oxidation, you all know bromine is our reducing agent. Okay? So this is what you need to know. Sometimes oxidation number can be a bit tricky. So please be careful. For me, I think electron method is easier. Okay? Oxidation number method sometimes is a bit trickier. So please be careful. Especially here. Why we don't times 2 for this? Because I'm looking for oxidation number. Oxidation number no need to take the sum. Understand? Okay, alright, next one. Can we copy another half equation? Here, our 2 iodide now is converted, become iodine coupled with 2 electron. Can we do the same thing? Why not? Let's list out the oxidation number. Come, I want everyone to go with me. What is oxidation number for the iodide? -1, yeah? Not -2, -1, okay? Because oxidation number no need to do the sum. Iodine on the right hand side is one species element, 0. Okay? -1 to 0, you can clearly see oxidation number increase. So, which species oxidation number increase? Br, right? Sorry, I. Get the I, So you just need to write this. Oxidation number of the I species. You don't need to specify I minus or I2, no need. Oxidation number, just write I, the species, that species, okay? I, the oxidation number increases. The oxidation number increases from -1 to 0. When oxidation number increases, the process is oxidation. Okay, I write, is it wrongly? 0 to -1, decrease. So right here I write wrongly, my bad. 0 to -1, this is reduction. Sorry for that. Okay, so we undergo reduction. This is oxidizing agent. My bad, I'm doing a mistake here. Okay, so now let's go for this. So in this case, -1 to 0 go up. So when oxidation number go up, it's oxidation. Now, guys, you must tell people who undergo oxidation. Whose oxidation number changed from -1 to 0? This fella, right? This fella from -1 to 0. This fella is called I minus. I minus got charge called iodide. Because it got charge, I have the word ion. Yeah? Iodide, ion, undergo oxidation. When iodide, ion undergo oxidation, iodide, ion automatic will become reducing agent. So this is what you need to know. Any question? Okay, now let's finish the last one. So we already do our redox analysis. Let's do the last thing. The last thing called observation. Now, let's do this. Let's finish it. Our observation. Observation always refer to our half equation. Always refer to the half equation and tell people what we can see. Okay, let's try this. The first half equation is bromine plus 2 electron become bromide. Okay, everyone. Bromine. Bromine is our halogen. The color is brown. Bromine is brown. Now the bromine accept 2 electrons became bromide. Bromide got charge. When you got charge, you call halide. All group 17 ion colorless. So brown to colorless. Okay? So you all can write brown to colorless, but you must specify who changed from brown to colorless. This brown color comes from Br2. Who is the Br2 in this diagram? Bromine water. Okay? So you all can write bromine water. Bromine water change from brown to colorless. Okay? So this is what you can write, yeah? Okay, second half equation. This one. 2 iodide become iodine coupled with 2 electron. Same thing. Let's look at the color. Iodide. Group 17 ion. All group 17 ion, they are colorless. So iodide now become iodine. Iodine is halogen. Halogen got color. Iodine is brown. So colorless become brown. So you must specify who changed from colorless to brown. This colorless belongs to iodide. From your picture, your iodide is this color, sodium iodide solution. So please mention the solution. Sodium iodide solution. Sodium iodide solution. Convert or change from colorless to brown. Not very hard. Okay, I hope when we do the second example, you do have a better understanding than the first one. Are you okay with that? They are the common recipe, yeah. But guys, one thing to emphasize is here. You all must be very careful when you list out oxidation number. Understand? Please remember this. When you want to figure out how many electrons you needed in the half equation, when you want to know how many electrons you needed, you need to find total charge. Total charge. But when you want to do the redox analysis using oxidation number, when you want to list out the oxidation number, you don't need to find the total. You don't need to sum everything. Clear? So please be careful when you should get the total, when you shouldn't. Please make sure you understand this. Okay? Because many people do some minor mistakes over here, so we should all have to be careful. Okay? Finish. So these are the concept for halide displacement you should know. Jot down on this. I will do the final touch. Then we will close up on halide displacement already. Okay, so let me finish it. So now we have we have covered 2 examples. Okay, we have covered 2 examples for your halide displacement. So let me give you a very quick verbal summary. Halide displacement, when you saw the word displacement, is all about gangster Moody concepts. Okay? So when you must able to differentiate halogen and halide. Halogen is coming from group 17, they are neutral. Halide is also coming from group 17, they have charge. Okay, so please be careful, okay? So make sure you know the name, chlorine and chloride, bromine and bromide, iodine and iodide, okay? You must know exactly which one to use. Okay, the name is so important. Alright, so as what we learned from last week, when you come to redox, try your level best to get the half equation first. Once you have half equation, you can use the half equation to do your redox analysis, okay? Redox analysis means apple to apple comparison among left and the right hand side. Okay, you have 2 methods you can use in redox analysis. The first method called electron method, the second method called oxidation number method. Make sure you master this method, okay? If you can't get the concepts, you have to practice more and more until you get the idea, okay? Because if you don't know these 2 methods, you're gonna feel it very hard for this particular chapter. Lastly, observation. You can always tell people what you can see by referring to the half equation, okay? Please remember, the color that we learned here today is a bit different from the color you learned in your Form 4 Chapter 4. Because in Form 4 Chapter 4, the chlorine, greenish yellow, bromine, the brown color, and iodine, purplish black is the case when all the halogen is in pure form, when they are pure. But for today, the chlorine, bromine, iodine, they dissolve in water. So when they dissolve in water, so the color will be a bit different. So okay? Okay, now, let me do the final things to close up with these subtopics, yeah? Okay, as we can see the color already, guys, you learned a moment ago on the color. Okay, this is the halogen, like what we say. Our halogen, we have chlorine, bromine, and iodine. Yeah. So as what we can see, these are their appearance. Okay, these are their appearance. Chlorine is a pale yellow color solution. Bromine is a brown color solution. Meanwhile, iodine also a brown color solution. So I need all of you to understand the problem that we are having first. Then only we figure out the solution together. The problem is these two. If you realize the bromine and iodine, the color same. Alright? Bromine and iodine, their color are same. So that is the problem. Today, when I give you a brown color solution and I say, this is a halogen, you have no idea this brown color is actually bromine or iodine. You get the idea? But today, if I give you a pale yellow solution and I say, class, inside here got halogen, you confirm, tell me that that is chlorine. Understand? So that is the problem. When we have a brown color halogen, we have no idea whether they are bromine or it is actually iodine. That's the problem here. So what we can do? So that's why you have to learn this thing. You have to learn something called confirmatory test. You have to learn something called confirmatory test for halogen. What it means by confirmatory test? Confirmatory test comes from the word confirm. Okay? If you want to confirm what halogen, what you should do, confirmatory test is a test to help us double confirm. This is the test to help us to double confirm or to validate. It helps us to confirm or validate the identity of halogen. So after you do this test, you will be very, very sure what halogen is there. Okay? So listen carefully how to do this confirmatory test. Eyes on here. So how are we going to do this confirmatory test? How to do this confirmatory test? I give you a picture. I want you all to imagine. We have a test tube. In the test tube here, we have halogen. And I purposely don't tell you what is the halogen now. So you have some unknown halogen. So inside here might be chlorine, might have bromine, might have iodine. I don't tell you. I want you to figure it out for me, okay? So how to validate, how to double confirm which halogen is there? You have to do this confirmatory test. So how you do the confirmatory test here? How you do the confirmatory test? You all should go to add, okay? You all should go to add a very special thing called organic solvent. You need to add some organic solvent into your halogen or into the sample. Guys, I want to revise with you what is organic solvent. Let's do revision. Let's do revision. Okay, in chemistry, solvent is actually a liquid. Solvent is a liquid for us to dissolve solid. Okay? Solvent is a liquid that we use to dissolve some solid. That's called solvent. Okay, there are so many solvents out there, but in general, your solvent can be packed under two big families. I repeat, we have a lot of solvent, a few hundreds of solvents out there, but all these solvents can be packed under two big families for SPM. If you go for higher level, there are much more family. Okay, but in SPM, there's only two families for solvent. The first family called water. Make sense? Everyone knows water is one of the solvent, right? Water can use to dissolve many substances. The second family is called organic solvent. You guys as a Form 5 student should understand this word a bit better. You learn this in the Form 4. Form 4 you've been exposed, you heard about organic solvent, but a lot of people might a bit blur in Form 4, which is normal. In Form 5, as a person who really learn about your Form 5 Chapter 2 carbon compounds, okay? You all should understand what is organic. I told you before, in chemistry, the word organic stands for carbon. Okay? In chemistry, when you see the word organic, means that that substance got carbon. Clear? If you recall back, we learned this in your Form 5, Chapter 2. I said before, what is organic? Anything got carbon is organic except CO, CO2, CO3. Clear? Anything got carbon, they are organic unless CO, CO2 or CO3. So organic solvent is any solvent that got carbon. Okay? Organic solvent is the special solvent that got carbon. Okay, for organic solvent, you must be able to recognize two important organic solvent. These two organic solvent you must know, yeah? You must know, Okay, organic solvent normally the name is very long. The name is very long and the name is very weird. I repeat, normally organic solvent the name is very long and their name is very, very weird. The first organic solvent you all must know in this chapter called tetrachloromethane. Tetrachloromethane. The name is very long. Okay? If you don't know how to write or spell the whole thing, take a piece of paper, copy for a few times. Okay? Second organic solvent is 1, 1. You write the number 1 for 3 times. So when you're 3 thingy, you write the word tri. You learned before. Okay? So 1 trichloro. But now you don't use methane, you go to use ethane, E-T-H-A-N-E, ethane. 1 trichloroethane. So these two names sounds very weird, they are long, they are organic solvent. Clear? Normally organic solvent, the name is very long and very weird. You must know these two. Okay? So whenever you see the question they wrote tetrachloromethane, when you see the question they gave you 1 trichloroethane, you know they are organic solvent. Understand? Now let's do this. So on top here, we go to use a dropper. We go to add in some organic solvent. You can add organic solvent. You can use either one. Tetrachloromethane or 1 trichloroethane is okay. You use either one here. So when you add in organic solvent to this fella, what you should do? You just need to shake the whole mixture. You shake the whole mixture. After you add your substance, you shake the whole thing. Upon shaking, you will see this thing. You will see at the end of the day, there are total 2 layers. There are total 2 layers are formed. You have 2 layers up there. Okay, and in SPM, you should only focus on bottom layer. Just focus on bottom layer will do. Okay, you focus on the bottom layer. This bottom layer will tell you some important thing. Everyone, look at here. Okay, so this is the bottom layer. Okay, and then this is the identity of your halogen. Okay. If the bottom layer now give you a nice yellow color, so you will be very confirmed to tell people that it is chlorine. Okay? So when the bottom layer is yellow, you will know that it's actually chlorine. Now, when you go and add organic solvent and shake the whole thing and the bottom layer is brown in color, when you have brown colored layer, it tells you that that halogen is bromine. Okay? Now, the most important one is the last one. That's why I put a star here. If your halogen is actually iodine, you are not getting the same brown color already. Okay? Now the color will be different. If you have iodine, your bottom layer will show purple. Are you okay with that? Okay? And this is very powerful. Because by doing this, you will be able to differentiate bromine and iodine already. Now I want everyone to imagine, now put yourself in this situation. Today, if I have a brown solution and we don't know this brown solution is actually bromine or iodine, so what we should do? We add in a few drops of organic solvent and shake the whole thing. Then you look at the bottom layer. If the bottom layer is brown, you know already this fella is bromine. If the bottom layer now is purple, you know already this fella is iodine. Are you okay with that? Yeah? So this is why you learn this. Because when you learn this confirmatory test, you can use it to double confirm who is the brown color here. Are you okay with that? You got me? Okay, I hope everyone can understand, can imagine what is happening, alright? Because if you don't do this confirmatory test, when you given a brown color, you really cannot tell that brown color is origin from bromine or iodine. But now once you add in the organic solvent and you shake the whole thing, the bottom layer will tell you exactly who it is. Are you okay with that? So please make sure everyone know why you learn this thing, and they are so important, okay? This is so important, okay? Make sure you know the steps here, okay? So I think that's it. So this is every single thing you should know for your halide displacement. Okay, any question? Alright, jot down this.